Welcome to our presentation about eutrophication and pollution in the Mississippi River Basin. Our group topic is Agricultural Practices and Environmental Impact B, and our group members are Bridget Baumler, Brian Mead, and Emmeline Martin. Just to quickly set the agenda for this presentation, the topics we'll be going over include an introduction to the history of pollution in the Mississippi River, which I, Brian, will be presenting, an overview of the system challenges, which will be presented by Emmeline, and finally, we'll be discussing two future policy recommendations, which will be presented by Bridget and myself. The Mississippi River Basin has been shaped by nearly 2 centuries of agricultural expansion, river modification, and land use change. Called the nation's breadbasket, the watershed stretches across 31 states and 2 Canadian provinces. The Homestead Act of 1862 encouraged settlement of the region, and homesteaders began converting the natural lands into agricultural lands, which increased soil erosion and reduced resilience to flood events. In the early 20th century, the federal government's river engineering projects, which were meant to improve navigation and reduce flood damage, ultimately disconnected the river from floodplains, reducing nutrient filtration through natural systems. With the Green Revolution came the wide use of synthetic fertilizers that destabilized soils and leached into the river system, resulting in excessive nutrient loads traveling downstream, which continues today.
All right, so I'm going to talk you through the different facets the agricultural industry's impact has had on water quality in the Mississippi River Basin and northern Gulf Coast, starting with environmental. Excess nutrients due to the heavy dependence on synthetic fertilizers flow into the Gulf, creating a hypoxic zone or dead zone, an area of oxygen depletion. This has created an environment unavailable for living organisms and most plant life. As a consequence, large algae blooms only promote the consumption of oxygen and growth of harmful bacteria. To the right, I have a map here produced by the Louisiana State University and NOAA, the National Oceanic and Atmospheric Administration. This was done in 2025 with the dead zone measuring, quote, below average 4,402 square miles, which equates to 2.8 million acres of habitat potentially unavailable to fish and bottom dwelling species. So we're looking at a really large chunk of area that it was considered below average. As of 2026, they are predicting a larger than average or above average zone. Data has not yet been produced of what that's going to look like exactly, but we'll see how that goes. Heading inland to agriculture, the reliance on synthetic fertilizers has negatively impacted the soil microbe and fungi diversity. These small organisms create soil structure for roots, provide nutrients for plants to grow, and defend against harmful bacteria or fungi. Without them, the soil structure is unstable, and when watered through irrigation, heavy rain, or river flooding, there is minimal water retention, and all those chemicals used to grow all the plant life leach into waterways, thus reinforcing the cycle of heavy fertilizer use. As a society, local communities are facing the blunt of it with concern with nitrate contamination in their groundwater or private wells that are used in daily life. Some studies have even produced um, results from these chemicals causing cancer and birth defects. To those visiting any state area linked to the Mississippi River, these elevated bacteria levels have closed beaches or tourist sites due to health risk. But agencies like the Mississippi River Gulf of Mexico of Mexico, America or Mexico Hypoxia Task Force of the EPA and NOAA work hand in hand collecting data and research to assess current chemical leach levels in different states during agricultural practices, the current hypoxic zone size slash chemical levels. They even predict the future map and determine steps to better the situation. Economic wise, though, the states that do rely on tourism and like their beaches and parks face the economic effects of that, and any revenue generated typically from seasonal tourism isn't there. Fishing that's found throughout the Mississippi and especially in the Gulf is now they've lost a chunk of that biodiversity that could typically be used immediately off the coast. So they've lost money there. And then any money spent by the EPA, NOAA, and universities for the solutions, research, and data, unless we do something to truly change our agriculture practices, we are just continually funneling money into research with no exact results.
Future policy recommendations. According to the Mississippi River Basin Legislative Cohort report published in 2026, the Wisconsin Department of Agriculture, Trade, and Consumer Protections offers producer led watershed protection grants that fund cost sharing initiatives, on farm demonstrations, and outreach efforts to assist farmers in adopting conservation strategies and innovative methods to improve water quality. These efforts support the goal of improving water and soil quality by reducing soil erosion and phosphorus loss from fields. The grant program has been active since 2015, with a 2026 press release from the Office of Wisconsin Governor Tony Evers stating a base funding for the program of $1 million in the 2021-2023 biennial budget was increased to $1.5 million in the two most recent budgets. The same release shares that producer led groups must work with a collaborator such as the County Land Conservation Department, University of Wisconsin Division of Extension, a nonprofit conservation organization, or the Wisconsin Department of Natural Resources for accountability, data collection, and provided support. The results from this state grant show promising results and a potential framework for reducing non-point source nutrient pollution in tributaries of the Mississippi River. By providing education for farmers, performing soil tests, and increasing conservative farming practices, Wisconsin has seen significant reduction of soil erosion and phosphorus field loss on 1.6 million acres of managed lands in 2025, according to the DATCP report in 2026. The challenges for implementation on a larger scale stem from a lack of sufficient funding, a lack of data, and means for collection, and the need for intergovernmental coordination.
In this section, we will be looking at the work being done by the Mississippi River Basin Legislative Cohort, as well as the Nature Conservancy, specifically looking at their investments in natural infrastructure and restoration projects. First, we'll be looking at the Mississippi River Basin Legislative Cohort, which is a group of 10 states that lie directly on the Mississippi River. The proposed goal of this cohort is to tackle severe flooding, drought, and agricultural nutrient runoff within the massive Mississippi River Basin while strengthening economic and community resilience. The cohort is actively working to replace gray infrastructure, such as dams and levees, with natural infrastructure, which includes things such as the reconnection of floodplains, the restoration of wetlands, and the construction of riparian buffers. Natural infrastructure can be cost-effective when compared to their gray counterparts, and also can aid in restoring groundwater reserves. Restoring wetlands can also create a natural filter for pollutants in the river and can help to minimize erosion. Similarly, the Nature Conservancy has a plan to build natural infrastructure, albeit from a slightly different and more urgent perspective. Over the past several decades, the Nature Conservancy, along with the Army Corps of Engineers, have built countless locks and dams along the Mississippi River. But now, they see these things as a mistake. While a total dismantling of this infrastructure is likely not feasible or even worthwhile, these organizations are shifting to a new systems thinking approach to management of the river, which will incorporate more natural infrastructure, such as river islands and berms, which can aid in creating greater forest biodiversity. In the past, these organizations have viewed each infrastructure project as siloed, but now that they are taking a systems thinking approach, they acknowledge that each action that they take in one part of the river will have an effect on the river as a whole. This new, holistic way of thinking will be vital for ecosystem restoration in the Mississippi River.